Hey everyone, in this video we're going to go over section 4.1, an introduction to polynomials and polynomial functions. Our main goal is by the end of this we want to be adding and subtracting polynomials. It really boils down to combining like terms. But before we get into combining polynomials, let's start with square one. Let's talk about what a monomial is. And so what a monomial is a constant, or a constant times some variable or variables raised to powers that are non-negative integers. I'll say that again. So a monomial is a constant. So a monomial can be something like the number 3 or negative 17 or 0, just a constant term. Constant terms times some variable or variables. By that, they mean a constant times a variable, or a constant times some variables, x times y. We could have, I don't know, negative 2x, y, z. These are all examples of monomials. Or a combination of variables raised to powers that are non-negative integers. Alright, so now we could have, say, 3x squared is a monomial, because it's a constant times a variable with a non-negative exponent. We'll say 2xy to the negative 3 is not a monomial, because that exponent was negative. So monomials, constant times a variable or some combination of variables, and those variables can have exponents, and all of the exponents, we'll say 5x squared y cubed z to the 11th, a constant times some variables, and all the exponents on the variables are non-negative integers. Remember, an integer by itself, well, that's plus or minus 1, plus or minus 2, plus or minus 3. We got to tack a 0 on out front, but this pattern continues on and on. So the positive or negative, any whole flat number. What a non-negative integer, well, that's 0, 1, 2, 3, 4, etc., etc. So we're talking about constant terms that's attached to variables with multiplication, and all the exponents are non-negative integers. So that's a monomial. What about polynomials? Well, a polynomial is just going to be many monomials. So we can take a monomial, say 3, and we can take another one, 5x squared, and polynomials combined two monomials with either addition or subtraction. So we now have a polynomial. X squared minus 3x plus 1 is a perfectly good polynomial. We can have stuff like 3x squared y cubed minus x squared y plus 1, or plus 11 is a perfectly good polynomial. Polynomials, like I said, they have the same restrictions as monomials. We're just taking a couple monomials and combining them with either addition or subtraction. We can also talk about polynomials in different amounts of variables. So 3 plus 5x squared, we can consider that a polynomial in one variable, because there's just x's in it. This is also a polynomial in one variable. We just changed the plus sign to a minus sign. And this polynomial is also a polynomial in one variable. So one variable, one variable, one variable. There's just x's. Down here, this is a polynomial in several variables. It's a polynomial of several variables because we have x's and y's in the same problem. Or in the same combination of monomials, I should say. So one variable, they're not talking about just x's as just a singular x as compared to an x squared. When they're talking about polynomials in one variable, they mean there's only one kind of variable. Or a polynomial in several variables, that's going to be any polynomial that has x's and y's and z's. You need a combination of different variables for it to be considered a polynomial in several variables. So now I want to give you a couple of vocab terms so we can develop a language needed to talk about polynomials. Thank you, Sophie. So let's consider the polynomial 2x cubed minus 3x squared plus 5x minus 4. A perfectly good polynomial. It's a polynomial in one variable because we just have x's. So our first word is term. A term is just a monomial. A monomial that is a part of a polynomial. So, all of our terms for this polynomial, our terms are 2x cubed, because that's a monomial. Another term is negative 3x squared. Another term is 5x. And another term is negative 4. So, those are all of our terms. I always think of polynomials as molecules, and terms are kind of like the elements of the molecule. The next vocab word is coefficients. Coefficients are the numbers in front of our terms. So our coefficients for this problem are 2, negative 3, 5, and negative 4. These are the coefficients. And be careful because that minus sign is attached to that 3, and that minus sign is attached to that 4. Polynomials can also have a constant term. And the constant term in a polynomial is the monomial without any variables. Constant term is a monomial without a variable. That's an awkward way to say this because negative 4 can definitely be written as negative 4 times x to the 0, because anything with an exponent of 0 is equal to 1, till you get to calculus, and there's some more to it then. But I don't. The constant term, yes, it technically has an x to the 0 on the end of it, but unless you've been doing math for a while, unless you're thinking for it, I think it's natural to say that this minus 4 doesn't have a variable attached to it. I think constant term that has definitely more of an intuitive definition. It's a thing on the very end. Like I said, it has no variables attached to it. I do have to put an asterisk right there and warn you that that's not a 100% way of thinking about it, because we definitely have an x to the 0 on the end. We just don't write it. But the constant term is just the number floating around on the end. So the constant term for this problem is just going to be the -4. This right here. The next vocab word is really a vocab phrase, and that's the degree. Degree of a term. So the degree of a term, you can think of it as the largest exponent or combination of exponents. Let's get another piece of paper. So the degree of a term, the largest exponent or combination of exponents. So let's go term by term. So our first term is 2x cubed, and the largest exponent in this term is 3. So we would say the degree of the monomial 2x cubed is 3. The next term, if we had -3x squared, well, the degree of -3x squared is 2. Then we've got a 5x. The degree of 5x is 1. And even though we didn't write it, there was definitely, you can think of it as a 1 floating around as the exponent on that x. And last one, we have this constant term, -4. And the degree of -4 is 0. Like I said over here. We can write -4 as -4x to the 0, and then we're looking for the largest exponent or combination of exponents, I want to say attached to the variables. So since the largest exponent in this monomial is 0, the degree of -4 is just 0. Now, taking it one step further, a degree, before we go there, I want to say this to clear something up. All of these were just this is just a polynomial in one variable. If we had, say, a monomial that was -4x cubed y squared. Now we want to know what is the degree of this polynomial. Well, the degree of the polynomial is the largest exponent or combination of exponents attached to the variable. And I need an s in there for good measure. Well, you might say, is that degree 3 or is it degree 2? And you'd say neither. -4x cubed y squared is of degree 5. Because 3 plus 2 equals 5. If we had 5x to the 7th, y to the 4th, well, the degree of 5x to the 7th, y to the 4th is 11. Because 7 plus 4 is 11. So when we're talking about degrees of terms, you're looking for the largest exponent. Be careful with these two. If students are going to make mistakes, they're probably going to make a mistake here or here. Unless we're dealing with these polynomials that have multiple variables in them. And the degree of the monomial, well, you just add the exponents. 3 plus 2 is 5, so the degree is 5. 7 plus 4 is 11, so the degree is 11. Kind of a trick question, but if we ask what's the degree of 3 divided by x plus 1, well, the degree is talking about exponents on polynomials. This is not a polynomial. So it doesn't make sense to ask about its degree. We're only going to ask you about degrees in reference to polynomials. So let's talk about the degree of a polynomial. A degree of a polynomial well, that's the highest degree of each of its monomials. So going back to our big polynomial, 2x cubed minus 3x squared plus 5x minus 4, well, this polynomial's degree is 3, because 3 is the highest degree of any of its monomials. If we had, say, negative 2xy cubed minus 7x cubed y squared plus 11x to the fourth y to the fourth minus 3, well, this is a perfectly good polynomial. All of our variables have non-negative, integers. And the degree of this polynomial, well, we go through. We want to check the degree of each of the monomials, and we want the one that's biggest. Well, the degree of this term is 4. Terms are separated by addition or subtraction, so that's one of our terms. Here's another term. This term, the degree of this term is 3 plus 2, which is 5. Here's another term. The degree of this term is 4 plus 4, which is 8. The degree of this term is 0. So the degree of this polynomial is the largest out of the degrees of their terms, which is 8. So the degree of that polynomial is 8. Don't get confused. Degrees of monomials versus degrees of polynomials. A polynomial is just going to be is going to have just one degree. Each monomial is just going to have one degree. You're not going to have a monomial or a polynomial that has 2 degrees. You can just talk about degrees of monomials, and a bunch of monomials come together to get a polynomial. And lastly, the final vocab terms are leading term and leading coefficient. Well, going back to this example we've been working with, our leading term is the term with highest degree. So the leading term in this polynomial is going to be 2x cubed, and the leading coefficient is the coefficient in front of the leading term. So in this polynomial, our leading coefficient is going to be 2. So these are the new vocab terms we're going to be using to talk about polynomials. Terms are just the little snippets that make up polynomials. A term is just a monomial that is part of a polynomial. Coefficients, they're the numbers floating around out front. Constant terms, that's the term that doesn't have any variables. The degree of a term, Well, you're just going through and looking at the highest exponent. Be careful degrees when we have multiple variables in each monomial. You have to add the exponents together. The degree of the polynomial, you go through and you pick the biggest degree, and the highest degree of one of your monomials is the degree of the polynomial. Over here, the highest degree was 3 of that monomial, so the degree of this whole polynomial was 3. Leading terms, they're the thing with the highest degree, and the leading coefficient is the number in front of the leading terms. So I'll give you one final example of that, or maybe two. Let's say we had 2x cubed plus 8x squared minus 17x minus 3. All of our terms, well, they're going to be 2x cubed, 8x squared, negative 17x, and negative 3. The degree of each term, well, the degree of this term is 3. The degree of this term is 2. The degree of this term is 1. And the degree of this term is 0. The degree of polynomial, well, that's going to be the highest degree, 3. The degree of this polynomial is 3. Then we can identify a leading coefficient and a constant term. Well, our leading coefficient, that's the number attached to our leading term. So our leading coefficient is going to be 2. And then, let's see, then our constant term is going to be negative 3. Be careful of that minus sign. So when they have one variable, it's fairly straightforward. Let's give you an example when they've got different variables. If we had 6x squared plus 8x squared y cubed minus 17xy minus 24 xy squared z to the 4th plus 2y plus 3. And we'll go through and we'll do the same thing. Our terms are going to be 6x squared, 8x squared y cubed, negative 17xy, negative 24 xy squared z to the 4th, 2y, and 3. The degrees of each of these terms, well, this is going to be of degree 2. This is going to be of degree 2 plus 3, which is 5. This is going to be of degree 1 plus 1 is 2. This is going to be of degree 1 plus 2 is 3, plus 4 is 7. This is going to be of degree 1 and degree 0. So those are the degrees of each of the monomials. The degree of the polynomial is going to be 7. So that means our leading term is actually going to be the negative 24 xy squared z to the 4th. So that means our leading coefficient is going to be negative 24. And finally, our constant term is 3. Knowing degree. The word term gets thrown around a lot. A lot of times you'll hear math teachers talk about terms of polynomials, terms of an equation. Knowing the word term and knowing degree. Typically degree, we're going to talk about degrees of polynomials. You can be asked about the degree of a monomial. But knowing degree, that's a big degree of polynomial by extension. Those are big vocab words. Leading coefficient, I trust you guys have heard the phrase leading coefficient. Terms is a big word, just so you know what I'm talking about. So the final thing with regards to, not to terms, I'm sorry, the final thing with regards to polynomials is that there's a bit of a convention. The convention is that we write polynomials when their terms are descending in degree. What does that mean? What by that do I mean? 12 plus x squared minus 7x. Well, this term has degree 0, that term has degree 2, and that term has degree 1. We want to write these terms with their degrees in descending order. So the first one would be 2, so we'd write x squared. The next one would be 1, we would write negative 7x. And finally, we would tack on our constant term, plus 12. If we say had 2 plus x to the 4th minus 5x squared plus 3xy, I'm sorry, plus 3x cubed y plus 7x y squared. Well, let's see, we have degree 0, we have degree 4, we have degree 2, we have degree 3 plus 1 is 4, and then we have degree 1 plus 2, which is 3. So the last step is to rewrite all of these terms with their powers, with their degrees in descending order. Notice how we've got two terms with degree 4. At this point, you would want to figure out, are we trying to write this as a polynomial in terms of x's or in terms of y's? It's typically to do things in terms of x's, so we could rewrite this in descending order as x to the 4th. Then to that we would add, oops, that was supposed to be a plus sign, sorry about that, x to the 4th plus 3x cubed y minus 5x squared plus 7xy squared plus 2. You can add or subtract in any order you want to in math, as long as you do it correctly. You can add in any order you want to. You just have to be clever about it. So it doesn't necessarily matter if you rewrite your polynomial. It could be convenient to work with it in this form as compared to, say, this form up here. But writing polynomials in that form is just a convention. It's something the mathematical community has agreed upon that we all sort of do. Is this more correct than this? No, these two polynomials are equal in every way, shape, and form, aside from the order that you wrote down the terms, so it doesn't necessarily matter. Read the directions, though. If you are instructed to write a polynomial with the powers in descending order, then be sure that you can do that. But yeah, for the most part, this is largely just a convention. But that's why you'll see, say a polynomial function. Well, we'll take a polynomial, say negative x squared plus 4x minus 1. This is a polynomial. If we want a polynomial function, well, we will call this thing p of x. It's common to call polynomials by a capital P. Just like we've been calling most functions by a lowercase f, g, or h, or something else. Typically, we call polynomials capital P. But just like the order in which we write our terms, calling a polynomial capital P is just a convention. This is, after all, a function, and it's written in function notation. There's nothing wrong with calling this thing f of x being equal to negative x squared plus 4x minus 1. But typically, I've noticed in books when we start getting into the polynomial section, they drop the f of x and they start to write p of x. It doesn't matter what you call the polynomial. You can call it p, you can call it f. I'm going to be consistent with the book and I'm going to call them capital P. And we can evaluate polynomial functions just the way we would evaluate any other function. If we wanted to know what p of 2 is, well, that means everywhere that we had an x in our original polynomial, we're going to replace it with a 2. Then we'll go through and solve. That minus sign will drop down. 2 squared is 4, plus 4 times 2 is 8 minus 1. That's a positive 4, take away 1 gives us 3. And we get p of 2 being equal to 3. We could do p of 10. And same thing, wherever we had an x in the original equals negative 10 squared. There we go. Wherever we had an x in the original, we're going to replace with a 10. That would give us negative 10 squared is 100 plus 40 minus 1. 100, negative 100 plus 40 is negative 60. Take away 1 is negative 61. And we get p of 10 is equal to negative 61. So evaluating polynomial functions is straightforward. It's just like evaluating functions. The only thing that is different between evaluating a polynomial function and evaluating a function is simply what we call the function. And like I said before, it doesn't matter if you call a polynomial p, f, g, h, whatever. They all are going to behave the same. You can think of that as just the polynomial's name or the function's name. This function is called capital P. And we go through and evaluate them like we would any other function. There's a lot we can do with polynomials. For now, we're going to focus strictly on different methods of combining polynomials. Next section, we're going to break polynomials apart. In this section, we're only going to put them together. So first off, we're going to talk about adding polynomials. For adding polynomials, and by extension subtracting polynomials, that's the next thing we're going to do. For adding polynomials or subtracting polynomials, all we're going to do is, first, we're going to distribute. Then, we're going to gather like terms. It's good measure. We're going to go through, and the final thing we're going to do is we're going to write these in standard form. We're going to write all of these polynomials with our powers with our terms decreasing in power. We're just going to rewrite at the very end. Put it in a form that's kind of more standard to look at. So, on your roadmap, first hurdle we got to clear is we want to add negative 3x cubed plus 2x minus 4. To that we want to add 4x cubed plus 3x squared plus 2. Perfect. So the first step we want to go through is we want to distribute. And what do I mean by distribute? Well, in this problem, we've got an addition problem. There really isn't anything we would have to distribute per se. So with addition, you don't have to worry about step 1. Step 2, however, is gathering like terms. And we want to go through and we go, okay, I've got a negative 3x cubed. Negative 3x cubed plus 4x cubed. Well, if I've got negative 3x cubed and I get 4 more, that would leave a positive x cubed left over. Well, then I've got this degree 2 thing. How about we have, well, we've got a 3x squared. No x squareds over here. So we're done with that term. Degree 1, well, we've got a 2x. And we have a constant term. I did them, nope. Negative 4 plus 2 gives us a minus 2. There we go. I already did step 3 as I was doing step 2. But the final step would be to rewrite these with our powers decreasing. We've got degree 3, we've got degree 2, we've got degree 1, we've got degree 0. So let's add, we can add, got 2 more examples of adding for you. Let's say we wanted to add 13 x cubed y plus 3 x squared y minus 5y. To that we want to add x cubed y. Then we want to add 4x squared y. And then we want to subtract 3xy. So we want to distribute. We're doing addition, so we don't really have to distribute. If that was a minus sign, that's why I keep talking about distribution. If that was a minus sign, we'd have to distribute across each of these addition and subtraction. We'll do subtraction problems here in a second. So we're done with our distribution process. Now let's go through and gather like terms. Well, I've got a 13x cubed y, and I've got another x cubed y. If I put them together, that'll give us 14x cubed y. Then I've got a 3x squared y and a 4x squared y. Bring those together, that gives us 7x squared y. I've got a minus 5y. That doesn't combine with anything. And neither does this negative 3xy. So be careful, because we've got a y over here and we've got an xy over there. They're similar, they have parts in common, but they're not the same overall. When gathering like terms, the entirety of the variable has to match. The entirety of the variable. These two didn't match perfectly, so we weren't able to combine them. Now we should, so we've gathered our like terms. Our final step is to rewrite. Well, this term is of degree 4, this term is of degree 3, that term is of degree 1, and that term is of degree 2. So let's rewrite these with our degrees decreasing. For 14x cubed y plus 7x squared y minus 3xy minus 5x. This would be our final answer, given that 3-step process. Like I said, there's nothing different about these two equations. This one is just written in more of a standard form, if you will. The final, oops, need another piece of paper. The final example for addition, we can keep our handy-dandy 3-part process out. Let's say we had 4ax squared plus 4bx minus 5, to which we want to add negative 6ax squared plus 8. Perfect. So we want to distribute. It's an addition problem. We don't have to worry about it. So we're on to gather like terms. We've got a 4ax squared and a negative 6ax squared. When we combine those, we get a negative 2ax squared. Then we have a plus 4 bx. And we don't have any bx's over here. And finally, we have a negative 5 plus 8 gives us plus 3, it would be. We've already got our powers decreasing, so this would be the final form for that polynomial. Distribute, gather like terms, and rewrite. So let's do an example where we actually have to distribute. Let's say we had a negative 5x squared plus 4, from which we wanted to take away 2x squared plus 3x minus 1. So this is our first subtraction problem. This is also the first problem we're actually going to distribute on. We want to take this minus sign, and we want to distribute it to each of our terms. So this left-hand side stays the same, and at this point you do not need to write these parentheses anymore. Negative 5x squared plus 4. We're going to subtract a 2x squared, we're going to subtract a 3x, and we're going to add a 1. So we've done our distribute. Now we want to gather like terms. Well, I got a negative 5x squared and a negative 2x squared. Together that gives us a negative 7x squared. Then we have, well, we've got a constant. We've got a 4 and then a 1. That gives us 5. And then we have a negative 3x. So that was step 1. This is step 2. Finally, step 3 is to rewrite these terms with their degrees decreasing. So we go from negative 7x squared minus 3x plus 5 for a final answer. Distribute to each term, gather like terms, rewrite them. Something bigger. Let's say we had 4, that's a typo. Let's say we had 4x squared minus 6x cubed y squared plus x squared y squared, from which we wanted to take away 4x squared y plus x cubed y squared plus 3x squared y cubed. Oh, ran out of space, and from that we would take away 8x squared y squared. So 4x squared minus 6x cubed y squared plus x squared y squared minus the quantity of 4x squared y plus x cubed y squared plus 3x squared y cubed minus 8x squared y squared. So the first thing we're going to do is we want to distribute this minus sign to each of our terms. And when you do this distribution process, we're not changing this leading polynomial any. We don't need these parentheses. They're there for grouping. They draw our eyes to that polynomial. So we don't need them. So I'm not going to write them. You can still write them if you want to. I just don't like having kind of barriers when I go to combine all my like terms. So we'll distribute that minus sign onto the 4x squared y. Gives us negative 4x squared y minus an x cubed y squared minus a 3x squared y cubed, and now plus an 8x squared y squared. So this was our distribution. We are done with distributing. Now we need to gather like terms. Well, this is the only 4x squared, so we'll leave it alone. And I like to cross them out when I'm done with them. Well, I've got a negative 6x cubed y squared, and I've got a negative x cubed y squared. Bring them together to get negative 7x cubed y squared. Then we have x squared y squared, and we got another x squared y squared, or we got 8 of them. So when we bring them all together, that gives us 9x squared y squareds. We've got a negative x squared y, negative 4x squared y, and we have a negative 3x squared y cubed. So we've combined all the terms that we can. We made sure that all of the variables matched identically. And the last thing to do is rewrite them with our powers decreasing, or with our degrees decreasing. This term is of degree 2, this term is of degree 5, this term is of degree 4, this term is of degree 3, and this term is also of degree 5. So we have two different terms we can pick as our leading term. It doesn't matter which one you pick for this sake. If we said that this was a polynomial of one variable, then we would pick the appropriate variable. But we can pick either of these to be our leading term. So I'll pick one of them, negative 7x cubed y squared, and I'm going to put the other, minus 3x squared y cubed. And we're at the 4, plus 9x squared y squared, minus 4x squared y, plus 4x squared, for our final answer. So, what are we doing in this section? Or what have we done in this section is a better way to start off. The biggest thing, well, what we started off with is we started off with some vocabulary and trying to find page 1. So we talked about monomials. Monomials, we only needed that term to start talking about polynomials because many monomials come together to make a polynomial. You might hear the term monomial for 1, you'll hear binomial for 2, you'll hear trinomial for 3, and anything above that we just call a polynomial. Poly means many. There's nothing wrong with calling a binomial a polynomial. And for our class, you're only going to hear me, I believe, say the words monomial and polynomial. But just know that if you're looking for help online, I highly suggest you guys are doing that. If you're looking for help online, they might talk about binomials and trinomials. That's just a specific kind of polynomial. So we talked about polynomials, what they are, and what they are not. We talked about terms. Terms are the little chunks that make up polynomials. Be careful because minus signs, students get tripped up on minus signs. Only addition separates the terms of a polynomial. Going back here, let me explain that a little bit more. We could rewrite this polynomial as 2x cubed. Minus 3x squared is the same as plus a negative 3x squared plus 5x plus a negative 4. And it's at those plus signs that we break up our polynomial into its terms. Coefficients. Coefficients are the numbers in front of your terms. I bet you guys have heard the word coefficient. Normally, I suspect you guys would have heard the term coefficient in terms of the leading coefficient. Our constant terms is the constant number tacked on to the end. Not all polynomials will have constant terms, so that's something to be aware of. Constant term, degree of terms. That's the highest, that's either the largest exponent or the largest combination of exponents. Then we talked about degrees of polynomials. All that is really just developing vocab, the words you need to know in order for us to have this discussion about polynomials. What we're doing in this section is working with polynomials. Polynomials are just fancy functions. They're bigger. They're not necessarily bigger per se. In your book, polynomial functions tend to have a lot more terms than just say regular old functions. But that's not a law. That's not a convention. That just happens to be the way it is in your book. So we developed some vocab. Now we're adding polynomials. Adding polynomials is just gathering like terms. Go through and gather all your like terms. Like I said, it's just a convention that we rewrite these polynomials in a specific order. But that's just a convention. You don't have to do that. The problem isn't wrong unless you were instructed specifically to write a polynomial in a certain way. So combining polynomials, we're adding them, gathering our like terms. With subtraction, you got to be careful, and you got to remember to distribute that minus sign to each of your terms. And then once you distribute your minus sign, then it's gather like terms and rewrite. Gather like terms and rewrite. Next time we meet, we're going to be working on multiplication and I believe division of polynomials. So this section, it's really introducing you to some vocab and getting your hands dirty working with them was something you guys should already understand. We were combining functions. This is just taking it one step further. So go off and do 1, 19, 21, 25, 45 through 57 every other odd, and then 65 through 77 every other odd. Let's see, this will be due, I don't have a calendar in front of me, so I will write on Blackboard when this thing is due. It's due a week from today, whatever today's date is. Also, for those of you who stuck around long enough, thank you for watching the video till the end. The university has extended the deadline for you guys to drop and not take an F till the 10th. I'm sure some of you are well aware of that. Because we have this radical redesign of the way the course has been going, the university wants to give you the opportunity to say this doesn't work for me, I want to try again next semester. So you have until the 10th to drop this class, and you should not get an F. I would definitely talk with a counselor or a registrar about it. But by my understanding, if you drop before the 10th, you don't get an F. On a personal note, I've gotten accepted to grad school 3 times, and I have 2 W's on my record. So it's not the end of the world if you get a W. And if you want to talk to me about what the rest of the semester is going to look like, how you're personally doing, shoot me an email. I'm more than willing to talk to you and get you caught up, make sure you know how you're doing, let you know what the expectations are for the rest of the semester. On that, I hope you guys all stay healthy, and if you have any questions, let me know. Have a nice day.